Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical from the chapter Machine Part A. So before starting our video, my suggestion is you have to watch the concept video first, then we have to learn how to solve the theory questions, then you come back to numericals. All those two videos are available in the description box. And we need to understand why we have to solve theory questions after that numerical, because theory question you will understand some logic. Those logic we are going to implement in our numerical video. So my suggestion is watch those two videos first, not only from this chapter, from all the chapters. Concept video we will teach you concepts, then the theory questions, whatever the theory questions you have in the textbook, we are solving everything. So once you learn both the things, then it is very easy to solve numericals. So all those videos are in the description box. The links for all the videos from all the chapters are available in the description box. Before starting our first numerical, my suggestion is you need to understand what is fulcrum, load, effort, where they are situated, and what class lever is that. All those things are taught in concept video. If you haven't seen it or if you don't know that concept, then it is very difficult to solve numericals. So first learn that. Okay, so we'll see our first question. A crowbar of length 120 cm has its fulcrum situated at a distance of 20 cm from the load. Calculate the mechanical advantage of the crowbar. You know, mechanical advantage formulas are very easy. Okay, we'll apply in all the questions, then you will understand. Okay, now listen. See, first you need to know what is crowbar. See, this is the crowbar. This is class 1 lever. How this is class 1 lever? Listen. See, this is the load, we have to lift it using the crowbar, correct? So here we have load, this is fulcrum and this is effort. Okay, so according to the diagram, which arm is large, load arm or effort arm? See, load arm only is this much, effort arm is this much. So which is greater? Effort arm. That you should know. Why? Because that is given in the question. See, the crowbar of length, total length. Okay, question number 1, total length is equal to 120 centimeter. Okay, now what else is given? The fulcrum is situated 20 centimeter from the load. That means fulcrum is situated 20 centimeter from the load. That means 20 centimeter is the distance between load and the fulcrum. So the distance between load and the fulcrum is called load arm, correct? If load arm is 20 centimeter, effort arm will be, how will calculate effort arm? From the effort to the fulcrum. So what distance will be? This will be 100 centimeter. How we got that? The total is 120. From the load to fulcrum is 20. From the fulcrum to effort will be 100 centimeter, because the total we have 120 centimeter. This is the diagram. Now we have to calculate the mechanical advantage. Mechanical advantage is equal to effort arm by load arm. See, mechanical advantage has one more formula. What is that? Mechanical advantage is equal to load by effort. This is one more formula. See, when we have to use this formula or that formula, very simple. If the lengths are given, okay, load arm in terms of centimeter or meter is given, we have to use this formula. Okay, so effort arm, arm means the length of the effort, that's it. If load value or effort value is given like 20 kg, 20 Newton, 20 kgf or 100 kgf, any value in terms of kg, kgf or Newton is given, we are going to use this formula. If the values are given in terms of centimeter or meter, you are going to use this formula. See, understand the concept. If the length is given, we have to use this formula. If the load value is given, how much it is weighing, then we have to use this formula. That's it. Okay, in this question we are talking about length, so we are not going to use this formula. Okay, effort arm is 100 centimeter and load arm is 20 centimeter. So this will be 5. What is the unit for mechanical advantage? There is no unit for mechanical advantage, because centimeter and centimeter will get cancelled. This is our final answer. Our second question, a pair of scissors has its blade 15 centimeter long while its handle are 7.5 centimeter long. What is its mechanical advantage? Very simple question. See. Okay. Listen. A pair of scissors has 15 centimeter long. What is that? Blades. So blades, these are called blades, right? See, this is why I am telling you need to understand the concept, then only numericals will be very easy. So next, they are talking about handles. Handles are 7.5 centimeter. Okay, now this is handle, correct, where we are going to put the effort. That means from the effort to the fulcrum, this point, okay, this point is called fulcrum. From the effort to the fulcrum is called effort arm, correct? This is effort arm. And from the fulcrum to the load, okay, what do you mean by load? If I use this scissor to cut any load, load is nothing but it can be any object, okay, that means this is the load. From the load to the fulcrum is called load arm. This one you have to know, which is effort arm, which is load arm. That is very much important. Okay, here we have to calculate mechanical advantage. Mechanical advantage is equal to effort arm by load arm. Why we are not using one more formula, which is load by effort? Because the values are given in terms of length. If the values are given centimeter or in meters, then we have to use this formula, or else other formula which we have discussed in the first question. Okay, effort arm is 7.5 centimeter. You don't have to write unit also. Then load arm will be 15 centimeter, correct? 7.5 ones are 2s are. It is 1 by 2 is nothing but, okay, 0.5. So what is the unit for mechanical advantage? Mechanical advantage, velocity ratio and efficiency doesn't have any unit. Question number 3. A force of 5 kgf is required to cut a metal sheet. A shear is used for cutting the metal sheets as its blades 5 cm long while its handle is 10 cm long. What effort is required to cut the sheet? First we will write the given data. While writing the given data, I will make you understand what are the given things so that we can easily calculate the effort required. Okay. Third question. Here 5 kg of effort is required. Okay, 5 kg of force is required. See, based on the given data, we are going to apply the formula. We have two different formulas for mechanical advantage, correct? So one of that formula we are going to use. Okay, listen. Load is 5 kgf. You have a confusion, I know, why we have taken load as 5 kgf. I will explain, don't worry. And blades. So blades means that is load arm, correct? Whenever we are talking about blades, or you can take instead of shear, you can take scissor also. In scissor, blades are taken as load arm. Do you remember the first question? Yes. So in that first question, we understood, okay, which one? Blades are load arm. That is nothing but load arm. That is nothing but blades. So blades are nothing but load arm. That is 5 centimeter. Then handles, where you hold it, handle, where we are applying the force, that is nothing but effort arm. From the effort, where we are applying the effort on the handles, correct? From the effort to the fulcrum is called effort arm. That is also given. Okay, that is 10 centimeter. Then what we have to find? Effort. See, effort is different, effort arm is different. Effort is nothing but how much force you need to apply to cut the object. Effort arm is nothing but the distance from the effort, where we are applying the effort, to the fulcrum is called effort arm. You know the difference, right? This is what we have learned in concept video. Okay, so you need to understand this one, very important, or else always there will be a confusion between effort and effort arm. Okay, listen, why we have taken load as 5 kgf. See, there are two ways to understand it. One is concept. If that is confusing, see the other data. See, in the final step, this one sentence, he is asking what effort is required to cut the metal. What effort? That means we have to find the effort, correct? So that is what we are going to find. See, first, see, load arm and effort arm is given. Okay, using these two we can find mechanical advantage, correct? Load arm and effort arm is given. So mechanical advantage is equal to effort arm by load arm. Once we get the mechanical advantage formula, we have one more formula for mechanical advantage. We'll substitute mechanical advantage formula there and we'll find the value of effort. Okay, load arm is 5 centimeter, then effort arm is 10 centimeter. So this will be 2. Mechanical advantage will be 2. So what is the one more formula we have? Mechanical advantage is equal to load by effort. Okay, see, load value is given in terms of kgf or kg or newton. That is why I am using this formula. If it is given in terms of centimeter, meter, I will use this formula. Next, load is given as 5 kg and we don't know effort, correct? We know what is mechanical advantage, that is 2 is equal to 5 by E. To find E, it will be 5 divided by 2. What is 5 divided by 2? Anything divided by 2 means we are making it half. Half of 5 is that thing by 2.5. That's it. Question number 4. The diagram below shows a lever in use. Okay, here load is given as 15 kgf. Okay, 15 kgf is nothing but 15 kg. Then this is fulcrum, that is effort. And now what we have to find? First one, to which class of lever does it belong? Second one, if AB is given as 1 meter and AF is given as 0.4 meter, find its mechanical advantage. Third question, calculate the effort. Okay, first we will write the given data, then we will understand everything. See, first one, A, to which class of lever does it belong? See, if the fulcrum is at the center, it is class 1 lever, correct? Okay, this is why your basic has to be strong. See, all these things we have taught in concept video. If you haven't seen it, the video is in the description box. Next, second question, if AB is equal to 1 meter, this is A and this is B, this will be 1 meter and AF is equal to 0.4. From here to here it is 0.4. Okay, complete length is 1 meter, AF is 0.4, then FB will be 0.6 meter. That's it. So now we can aramse find mechanical advantage. Mechanical advantage has two formulas, correct? So load is given, correct, and effort is not given. We cannot use load by effort, but this is load, correct? So from the load to the fulcrum is called load arm. From the effort to the fulcrum is called effort arm. Both values are given, correct? Effort arm and load arm. We'll use the effort arm load arm formula. Effort arm by load arm. Okay, what is effort arm? From B to F. Okay, effort arm is nothing but F to B or B to F, anything is fine, and here A to F, correct? So F to B is 0.6 and F to A is 0.4. This is nothing but 4. See, basic mathematics skills you should have to solve the numericals faster. So this will be 2s are 3s are 3 by 2 is nothing but 1.5, correct? Okay, next, mechanical advantage we are finding. What is the unit? No unit. Now once we find the mechanical advantage, it is easy to find effort because load is given. What is the one more formula for mechanical advantage? Load by effort, correct? Load is 15 kgf. We don't know effort, okay, but mechanical advantage value we found, that is 1.5, correct? So if you want effort, divide it. So 15 divided by 1.5 will be equal to, see, to remove the decimal point, I'll put 1 0 here. 15 ones are 15 tens are. So effort will be 10 kgf. That's it. See, one important point you should know. If the load is given in terms of Newton, effort, whatever the effort you are going to calculate, okay, that will also be in Newton. If this is in kg, this will also be in kg. If this is in kgf, this will also be in kgf. In some questions, load and effort value will be given. Load will be 15 kg, effort will be 15 kgf. No need to worry about it because kg will be equal to kgf. That's it. So you need to understand the units also. Question number 5. A man uses crowbar of length 1.5 meter to raise a load of 75 kgf by putting a sharp edge below the bar at a distance 1 meter from his hand. Okay. Draw the diagram of the arrangement showing the fulcrum, load, effort with their direction. State the kind of lever. Calculate load arm, effort arm, mechanical advantage, effort needed. Okay, all these things are very easy. First we will write the given data. Okay. See, the total length is equal to 1.5 meter. Okay. Next, to raise a load of 75 kgf, load value is given. Okay. Remaining things we will calculate arms. Okay, listen. First you need to understand what is crowbar. See, crowbar is a simple machine where we use it to lift a load. Okay. See, we'll put below the load and we'll use it like this, applying an effort. See, I will hold it here and I'll push it downwards. Okay, I'll push it downwards. So effort arm, this is called effort, this is called fulcrum, and this is called load. This is what we have learnt in first question, right? Okay, listen. Now load is here, fulcrum is here, effort is here. If the fulcrum is at center, which class lever is that? Class 1 lever. Okay. Now effort is in downward direction and load, see, what do you mean by load? The weight of the object, correct? The weight of the object will always be towards the center of the gravity. So the load direction will also be towards the center. So diagram is done. That means A is equal to done. B, state the class kind of lever. Class 1 lever. See, if the fulcrum is at center, class 1 lever. Next, we have to calculate load arm, effort arm and mechanical advantage. There is one more data is given. See, 75 kgf by putting a sharp edge below the bar at the distance 1 meter from his hand. See, there are two values are given. Total length is 1.5 and there is one more value is given, that is 1 meter. 1 meter. That means, see, in crowbar you know which has the longer hand, effort arm, correct? See this diagram. This is greater or this value is greater, from the effort to the fulcrum is greater. So two values are given. The total length is 1.5 and 1 meter is given from the hand, where you are going to apply the effort, where you are using your hand to hold it here, right? So from the hand it is 1 meter. That means, okay, this distance is 1 meter and from the load to effort will be 0.5 meter. Okay, so from the load to fulcrum it is load arm, from the effort to fulcrum it is effort arm. Okay, now we have got the values of load arm. Load arm is equal to, no need of calculating anything, this is for 1 mark, just identify the values. Load arm is 0.5 meter, effort arm is 1 meter, then mechanical advantage will be effort arm by load arm. Effort arm is 1 meter, load arm is 0.5, anything divided by 0 becomes double, so it is 2. Okay, it is 2. Mechanical advantage is equal to 2. So what is the question? They are asking us to find the effort needed to lift the load. So we have to find the effort. So we have load, we have mechanical advantage. How to find effort? We have one more formula for mechanical advantage. What is that? Mechanical advantage is equal to load by effort, correct? So what we have to find? Effort. Effort is equal to load by mechanical advantage, correct? So see, you don't have to write all these things. First see, you need to understand when we are solving the numericals, first mark is always given for the substitution. Write the formula, substitute the values properly in their SI units. If the values are not in SI units, you are never going to get the marks. See, here this mechanical advantage, efficiency and velocity ratio doesn't have any units. So without substituting the values in their SI unit also, you will get the proper answer. No need to worry about that. But in other numericals, in other chapters, all the values before substituting, make sure it is in SI units. Okay. Now, load is given as 75 and mechanical advantage we got it as 2. The final answer will be 37.5. What we are finding? Effort. What is the unit of effort? That depends upon load. What is the unit of load? kgf. Effort will also be kgf. That's it. Question number 6. A pair of scissors is used to cut a piece of cloth by keeping at a distance 8 cm from the rivet and applying an effort of 10 kgf by fingers at a distance 2 cm from the rivet. Okay, first you need to understand the concept. What we are using? Pair of scissors. Again, this we have used in one of the questions, correct? Don't worry about the diagram. I know it is very bad. See, rivet is nothing but the fulcrum. You need to understand that. Rivet is nothing but the fulcrum. So, a pair of scissors is used to cut a piece of cloth by keeping it at a distance of 8 cm from its rivet. See, what we are cutting? A piece of cloth. Okay, that is nothing but load. Load is related to 8 cm. That is nothing but load arm. So, load arm is nothing but 8 cm. Next, see what we are cutting? Cloth, right? Cloth is nothing but load. Load is related to 8 cm. That is nothing but load arm. Then we are applying an effort of 10 kgf. So, effort is given. So, this is load arm is equal to 8 cm and effort is equal to 10 kgf. Okay. And applying an effort of 10 kgf by fingers at a distance of 2 cm from the rivet. 2 cm from the rivet. See, load arm we got at 8 cm. Other remaining thing is the effort arm. Effort arm will be equal to 2 cm. You can understand in this way, or see, effort is applied by your fingers. Okay, that means effort arm, correct? So, all these data are given. We'll see what we are going to find. First one, the mechanical advantage of the scissors. So, this one we have to find. First one. Second one, load. Load offered. Third one, how does the pair of scissors act as a force multiplier, as a speed multiplier? That depends upon the value of mechanical advantage. First we will find all these things, then we'll go for the third one, whether it is a force multiplier or a speed multiplier. Okay, listen. To find mechanical advantage, there are two formulas, correct? Effort arm by load arm. If that is not given, then load by effort is one more formula. See, load arm and effort arm is given. Effort is given, load we have to find. So, mechanical advantage formula will be effort arm by load arm, because both the values are given. Effort arm is 2 cm and load arm is 8 cm. Okay. So, this will be 1 by 4, correct? 2 1s are 2 4s are 1 by 4 is nothing but 0.25, correct? What is that? Mechanical advantage. So, first one done. Second one, load we have to find. Using mechanical advantage, we have one more formula, right? That is load by effort. What we have to find? Load. So, this will be, load will be mechanical advantage into effort. Mechanical advantage is 0.25. Okay, into effort. What is effort? 10 kgf. Okay, 2.5 kgf. Why I am using kgf? What we are finding? Load. See, what is the unit of effort? Effort is in kgf. That is why load will also be in kgf. Okay, now the third one. See, whether it is acting as a force multiplier or speed multiplier. See, that depends upon the mechanical advantage. If the mechanical advantage value is more than 1, if more than 1, then it acts as a force multiplier. You are getting my point? If the mechanical advantage value is more than 1, then it is force multiplier. If it is less than 1, it is speed multiplier. So answer for this question is okay. Question number 7. It's a very important and very logical questions. So if you understood the concept, then it is very easy to solve. So each and every data, given data in all the numericals are important. What is given, from where it is given, all those things are very much important. You will understand the importance of all these things in this question. We will write the given data step by step according to the sentence. A 4-meter long rod of negligible weight is to be balanced about a point 125 centimeter from one end. See, 4-meter long, okay, rod. So it has to be balanced. Balanced means balanced at a point 125 centimeter from its one end. So they haven't mentioned which end, correct? So if we are going to balance this 4-meter long, how we can balance it? With the help of fulcrum, correct? With the help of fulcrum. That fulcrum has to be situated at 125 centimeter from one end, any end. You can take this end or that end. We'll take from this end only because the calculation will be much easier. See, at this point, this is 0 centimeter, right? 4-meter long means this is 400 centimeter. Okay. Next, at 125 centimeter, we have to balance the scale. See, assume this is 125 centimeter. So this point is 125 centimeter. Here we are placing the fulcrum at one end, from this end to 125 centimeter. Next, a load of 18 kgf is suspended at a point 60 centimeter from the support on the shorter arm. Which is the shorter arm? This is the shorter arm, and they are telling a load of 18 kgf. Okay, one load is kept here somewhere. Okay, that is nothing but 18 kgf. This is nothing but load, correct? A load is suspended, okay, at 0.60 centimeter from the support. Very important word, 60 centimeter from the support. See, that means it is not placed at 60 centimeter. Okay, from 0 to 60, so it is, the load is not placed at 60 centimeter. The 60 centimeter is the distance from the fulcrum to the load. See, understand the question. A load of 18 kgf is suspended at a point 60 centimeter from the support. This is the support. From the support to the load, the distance is 60 centimeter. Very important things. Okay, if you miss this one, you will get some answers that will be completely wrong. You need to understand, they are not saying 60 centimeter from the shorter arm. They are saying 60 centimeter from the support. Next, so all these things are done. Now we are going to solve the questions. This is very important diagram. Okay, question number 7. Okay, now first, a weight W is placed at a distance of 250 centimeter from the support. So see, to balance it, somewhere we are going to place a weight. That is nothing but effort. If this is load, this will be effort to balance it, correct? Now where this is placing, a weight is placed at a distance of 250 centimeter from the support. See, it is not placed at 250 centimeter point. It is placed somewhere. So the distance between the support and this one weight is 250 centimeter. This is very much important. From here to here it is 250 centimeter. Okay, now this is completely related to the principle of moments. Do you remember the numericals which we have solved from the chapter 4 part A? So based on that concept. Okay, so in this concept, first, this is based on principle of moments. So that is nothing but anti-clockwise moments is equal to clockwise moments. You know that, right? You can write that. So what you are going to write in the second step, anti-clockwise moments is equal to clockwise moments. Below that, W1 x1 will be equal to W2 x2. See, first you need to understand, we have learned this. Again I am going to teach you. W1 x1, W2 x2. W1 and W2 will be weights. W1 will be this side, W2 will be that side. So W1 value is nothing but load, correct? What is x1? x1 is nothing but from this load, W1, from this load, what is the distance from this load to fulcrum? Okay, that is x1. W2 will be the value of this effort, that is what we are going to find. X2 will be from this load or effort, okay, what is the distance from this effort to the fulcrum? Okay, all these things we should know. Okay, next W1 is nothing but load, that is nothing but 18 kgf into, don't worry about the units. Why? Because both the sides we have same units, so that will get cancels. Now 18 x1 is nothing but from the load 18 kgf load to the fulcrum support. What is the distance? It is given as 60 centimeter. Correct? 60. W2, we don't know the value of W. Correct? That is what we are going to find. W2 is nothing but W there. Then, okay, into x2. What is x2 value? From the W to the fulcrum. What is the distance? That is 250 centimeter. See, in different question they may confuse you with different words, but you need to understand the concept. If you understand the concept, then writing the values and getting the answer, that's it. So to find W, it will be 18 into 60 by 250. Okay, 0 and 0 get cancels. So once you solve this one, W will be 4.32. 4.32. What is the unit of W? What is the unit of W1? That is in kgf. W2 will also be nothing but W2, or the extra weight is nothing but kgf. That's it. Okay, now we'll see the remaining questions. If weight 5 kgf is kept to balance the rod, find its position. Okay, listen, instead of this weight, now because of this weight the scale is balancing. Okay, see the second question. If the weight 5 kgf, if another weight, different weight 5 kgf is kept to balance the rod, instead of this weight 5 kgf weight is kept to balance the rod, find its position. Same method. See, now what they are telling, instead of this value 250, okay, for a second sub question I am erasing it. Second question is different. Listen, see, 5 kgf weight is given, that is nothing but effort. This is W2, correct? 5 kgf weight is given. Where we have to keep this one? Somewhere here. This is a different question from the sub question 1. So weight 5 kgf is given. We have to place it somewhere so that scale will be balanced. That means this side will remain same. Only that side we are making the changes. So again same formula, principle of movement. W1 x1 is equal to W2 x2. W1 x1 is equal to W2 x2. Here W1 x1 remains same. That is 18 into 60. Here W2 value is given 5. We have to find the value of x2. We have to find the value of x2. To find x2, it is 18 by 60 by 5. 5 ones are 5 12s are. 12 into 18 will be 216 centimeter. So now we got x2. What do you mean by x2? x2 is nothing but the distance from this load, okay, load or effort to the fulcrum, correct? The distance between this effort to the fulcrum, the distance between these 2 points. But what they are asking, find its position. Position means at what point we have to place this. Okay, so from here to here it is 216 centimeter. Okay, this is 216 and this will be 125. So position will be, okay, 125 plus 216. If you add it, we will get the answer directly. That's it. Question number 8. Okay, in few questions we have to draw the diagrams, and that too based on the given data. Few things will be confusing, but if you understand the concept, it is very simple. We'll see that. A lever of length 9 cm as its load arm 5 cm. The total length of a lever is 9 cm and the load arm is 5 cm and the effort arm is 9 cm long. See, the total length is only 9 cm and they are telling effort arm is also 9 cm. What do you mean by that? The total length is 9 cm. Effort is also 9 cm. That means, what do you mean by effort arm? From the effort to the fulcrum. So assume we have fulcrum here. Okay, fulcrum. From here to the effort, it is 9 cm. The total length is also 9 cm. That means effort is kept somewhere at this end, one end. So this is effort. Why I am writing the upward direction, you will understand. And one more given data, load arm is 5 centimeter. Okay, from what is load arm? From the fulcrum to the load, it is 5 centimeter. Okay, this is 5 centimeter and this is load, and the direction will be downward direction. Why I have got to know that the direction are opposite? Why it is not same? Why load is always downward? Why effort is always upward? See, what is the use of fulcrum? To balance the scale. To balance the scale. If the fulcrum is here and load is here 5 centimeter, what is the direction of load? What do you mean by load? Load is nothing but the weight of the object, that will be always in downward direction, correct? So downward direction. And how we can balance this scale? If I apply the effort in downward direction, do you think it is going to balance or it is going to fall? It will definitely fall. To balance it, effort will be in upward direction. Which class lever is this? Class 2 lever, correct? Class 2 lever. In class 2 lever, effort arm is greater than the load arm. So in class 2 lever, the direction of effort and the load will be in opposite direction. So this is what we have learnt in concept video. That is why I suggest you to watch that first, then come to theory. After learning the theory concept, that means all the theory questions which is there in your textbook, we have solved everything. Those two videos are available in the description box. Watch that, then you will understand these things. See, for this question, this diagram is only important. If the diagram is wrong, you will not get any mark. So very important to learn all those things. Now we'll see the question. Draw the diagram of the lever showing the position of fulcrum and directions of both load and effort. That's it. Fulcrum, load, effort and its directions. Okay, next. What is the mechanical advantage and velocity ratio if the efficiency is 100%? So first we have to find the mechanical advantage, then velocity ratio, and one hint is given, efficiency is given as 100%. This is the symbol for efficiency. First we will find the mechanical advantage. Mechanical advantage is equal to, see here, load arm and effort arm is given. So we are going to use this formula, effort arm by load arm. Effort arm is nothing but 9 centimeter and load arm is 5 centimeter. 9 divided by 5 will be 1.8. What is the unit of mechanical advantage? No unit. Now we'll talk about this statement. Okay, once we found this one and efficiency is given, we can aramse find velocity ratio, correct? So what is the formula? Efficiency is equal to mechanical advantage by velocity ratio. Okay, if the efficiency is given as 100%, that is nothing but 1, correct? 100% is nothing but 1. How can you get rid of 100% percentage? Any value, whatever the value is given, divided by 100 to get rid of this percentage. 100 divided by 100 will be equal to 1. So efficiency will be equal to 1. Mechanical advantage is 1.8. We have to find velocity ratio. Velocity ratio will be equal to 1.8. So again, velocity ratio also doesn't have unit. Now there is one more question. What is the mechanical advantage and velocity ratio if the efficiency is reduced to 50%? Initially we have 100%. Okay, if it is reduced to 50%, what will be the mechanical advantage and velocity ratio? First thing you need to know, efficiency will not affect velocity ratio. Keep this in mind, very important point. That is why I am telling concept videos are very important. All these informations, important notes are given in concept video. Efficiency will not affect velocity ratio. If efficiency increases or decreases, it will not affect velocity ratio. So if efficiency is 50%, then they are asking mechanical advantage and velocity ratio. Okay, so in this method, whatever in this formula, if we substitute the values, we will get the answer. So first thing is, if efficiency reduces to 50%, how much it has reduced? Half of the original value, correct? Half of the original value. If efficiency is 50%, okay, half of the original value, mechanical advantage will also become half of its original value. What is the original value? It's 1.8. Half of it will be, mechanical advantage will be equal to 0.9 and velocity ratio will remain same. Question number 9, which is very similar to the previous question. Okay. The order of questions are same, so we'll see one by one. See, they have given one diagram of lever and we have to identify to which class of lever does it belong. Option A, question A, which class lever is that? Okay, if the load is at the center, it is class 2 lever. See, don't use first class lever, second class lever and third class lever. Okay, it is class 1, class 2, class 3 levers. Okay, next. If FA is equal to 80 centimeter and AB is equal to 20 centimeter, find its mechanical advantage. Very simple question. FA is 80 centimeter and AB is 20 centimeter. Okay. See, this is nothing but load. Load is directly given. From load to fulcrum, it is 80 centimeter. What do you call this as? From load to fulcrum is called as load arm, correct? Then what do you mean by effort arm? From the effort to the fulcrum, correct? Do you think from the effort to the fulcrum the direct value is given? No. See, from A to B is given. A to B, we don't have any notations like load arm, effort arm, nothing. A to B is one value which we don't require. But what we require? We require from effort to fulcrum. That is nothing but effort arm. Okay. So what are the values they have given? We have to utilize it to find what value we want. What do you mean by effort arm? From the effort to the fulcrum. Okay. So that is 100 centimeter. Okay, so here load arm is directly given 80 centimeter and effort arm is 100 centimeter. This is important. 80 plus 20. Next, mechanical advantage is equal to effort arm by load arm, that is nothing but 100 by 80. Okay, 2 4s are 2 5s are, that is 1.25. What we are finding, that is important, mechanical advantage. What is the unit of that? There is no unit for this, so this is our final answer. Now we'll go for part C. Okay, we have to find the effort value. Okay, to find effort value, at least we need load value and mechanical advantage, correct? See, load value is given in the question, mechanical advantage, that is what we found just now. So which is the one more formula for mechanical advantage? Load by effort. What we have to find? Effort. So that will be load by mechanical advantage. Okay. Now see, load value is 5 kgf and mechanical advantage is 1.25. The answer will be 4. So what we are finding? Effort. What is the unit of effort? That depends upon load. What is the unit of load? That is kgf. So effort value will also be kgf. Question number 10. The figure shows a wheelbarrow of mass 15 kg carrying a load of 30 kgf with its center of gravity at A. The point B and C are the center of wheel and the tip of the handle such that horizontal distance between AB is 20 cm and AC is 40 cm. See, in some cases they won't give you the diagram. They will give you only this much. In that case you have to draw. Okay, if they are asking it. If they are not asking it also, if you draw it, you will understand the concept properly. So for the safer side, we will draw the diagram. See, you don't have to draw it exactly like this anyhow. Okay, however, it is easy for you just to understand the concept. Okay, listen. So there is a wheelbarrow. The mass of the wheelbarrow is 15 kg. The complete mass of the wheelbarrow is 15 kg and it is carrying 30 kg load. Okay, 30 kg load. Okay, kg, kgf both are fine. Okay, because kg is equal to kgf. Now we have to find load arm, effort arm, mechanical advantage, and they have given load. We have to find effort. The same procedure, but if you understand the concept properly, we can answer it. Okay, first we will find load arm, effort arm. Okay, then we'll go for mechanical advantage. Okay, listen. To find load arm and effort arm, there is no calculation required. Just an analysis is enough. Okay, listen. What do you mean by load arm? The distance from the load to the fulcrum. First you need to understand which is load, which is fulcrum, and which is effort here. Okay, see where you are holding the handle. Okay, that is nothing but effort. This is effort, correct? Okay, where is the load? What you are carrying? It may be sand or anything. Okay, iron pieces or anything. But where is the load? That is here, correct? So at point A is called load. Okay, at point C is called effort. This is called as fulcrum. Okay, this is fulcrum. Now what is load arm? From the distance from the load to fulcrum, that is given in the diagram, or else it is mentioned in the question. Okay, now from load to fulcrum it is 20 centimeter. So load arm is 20 centimeter. Effort arm is the distance from effort to fulcrum. Effort to load is 40. See, we need this complete distance, correct? The distance from effort to fulcrum is called effort arm. The complete distance is 40 plus 20, that is 20 centimeter. That's it. So once you find these two, mechanical advantage is equal to effort arm. Sorry, this is for 20 plus 40, that is 60. Effort arm by load arm. So effort arm is 60, load arm is 20, so that is 3. No unit for mechanical advantage. Okay, then they are asking for effort, minimum effort required to carry this load. Okay, what is the another formula for mechanical advantage? Load by effort. Okay, and effort will be equal to load by mechanical advantage. What is the load? This wheelbarrow is carrying 30 kg of load, correct? So load value is 30 kg. Is it correct? No, it is completely wrong. Okay, I'll give you one example. Assume you're pulling water from the well. Okay, from the well using a bucket. So bucket is carrying around 50 kg of water. 50 kg of water. Do you think that is the only load we are carrying? No, right? We are lifting the bucket also. So the weight of the bucket and also the weight of the water. The complete is called load. In the same way, here the weight of the wheelbarrow is 15 kg and you are carrying 30 kg. So the complete weight you are carrying is 45 kg. So this will be 30 plus 15 kg divided by 3. That is nothing but 45 divided by 3. That will be 15 kg. See, if you know the meaning of mechanical advantage, okay, aram se you can calculate all these things. Okay, that's it. Question number 11. The diagram below shows the use of lever. This is the diagram and we'll go one by one. Okay, the first sub question. State the principle of moments as applied to the above lever. See, principle of levers, for all the levers remain same, but the load and effort value will keep on changing. So we'll see how we can write this. See, principle of levers is equal to moment of load about fulcrum is equal to moment of effort about fulcrum. Okay, don't use F and E directly in the exam, write it in the expanded form. Okay, now moment of load about F. So what is the distance now? See, that is a moment of load means load into, okay, load into load arm. What is load arm? This is considered as load. What is load arm then? From B to F, that is F into V is equal to moment of effort about fulcrum. That means where is the effort? At A. So E into effort arm. E from effort arm is nothing but E to F. That is nothing but A to F. So AF or FA both are fine. So this is called as principle of moment. That's it. Second sub question. To which class of lever does it belong? Give an example of this class of lever. Very simple. Listen. First we need to find where is the effort. Effort is at the center. If the effort is at the center, it is class 3 lever. It is not third class lever, it is class 3 lever. So class 3 lever, and they are asking for example also, right? See, example, the oar, OAR, okay, which we use it for boating. OAR, which is used for boating. It is an example for class 3 lever. Next, we'll go for part C. Okay. If FA is equal to 10 centimeter, FA is equal to, from here to here it is 10 centimeter, and AB is equal to 490 centimeter. This is A and this is B. This distance is 490 centimeter. Okay. Now we have to find mechanical advantage and the effort required, because load is given there. Okay. Now we'll go one by one. First we'll find which is load arm and which is effort arm. Load arm. What do you mean by load arm? Load arm is nothing but from the load from the B to fulcrum. See, this distance is 490, but what distance we want? From B to F. Okay, that is load arm. Completely it is 500 centimeter. Effort arm is equal to from the effort to the fulcrum, that is from A to F, that is 10 centimeter. Okay, then mechanical advantage is equal to effort arm by load arm. Correct. Effort arm is 10 centimeter. See, I am substituting directly. Don't do it in the exam. First write the formula, then substitute the values. Okay. Load arm is equal to 500. Okay. 1 by 5 is equal to 0.2. 1 by 50 is equal to 0.02. This is the mechanical advantage we require. See, for the next calculation, see, before this decimal, what was the answer? 1 by 50. You can use 1 by 50 also for the next calculations if we have, because if we are using 0.02, that may be difficult for the calculation, or else if you are okay with the decimal, you can go with it, or else we can also use 1 by 50 for the further calculation. So what we have to find, that is nothing but effort. Correct. Effort is equal to, see, from the previous question I am deriving the formula for effort, so we will write it directly. Effort is equal to load by mechanical advantage. Load is equal to, that is given as 50 Newton. 50 Newton. Mechanical advantage is 0.02. You can also use 1 by 50 here. Okay. Next. So I'll make this simple. After decimal there are 2 digits. So I'll put 2 zeros divided by 2. Okay. To get rid of decimal. If you are using any different method, it is fine. What we want just the answer, final answer. See, keep this in mind. Again I am telling you, first mark is always given for the substitution. Keep that in mind. If the substitution is wrong, if you write the correct answer also, somehow you will never get any mark. Always the first mark is for substitution. Keep in mind when it comes to numericals. Okay. Now 5000 divided by 2 will be equal to 2500. Okay. What we are finding? Effort. What is the unit of effort? That depends upon load. What is the unit of load? Newton. So unit of effort will also be Newton. That's it. Question number 12. A fire thong has its arm 20 centimeter long. The complete length is 20 centimeter. It is used to lift a coal of weight 1.5 kgf by applying an effort at a distance of 15 centimeter from the fulcrum. Find the mechanical advantage of fire thongs and effort required or needed. Okay, first see, in this question they have not given the diagram. So better you can write the diagram to understand the question. Listen, fire thongs will be somehow, okay, like this. Okay, this is the fulcrum. Somewhere here, okay, somewhere here, anywhere here or here, somewhere here, we are going to apply the effort. Okay, here holding this one, this is where we are going to hold the coal. That is what they are talking about, coal. Okay, so this is a coal is nothing but load. Okay, now what they have given, the complete distance is 20 centimeter, and for the effort arm, see, they have given by applying an effort at a distance of 15 centimeter, okay, from the fulcrum. So from the fulcrum to effort it is 15 centimeter. If you know this one, see, if you understand this one without drawing the diagram also it is fine. For your understanding I am writing the diagram. Now we got effort arm and the load arm. We can aramse find mechanical advantage. Mechanical advantage is equal to effort arm by load arm, correct? Effort arm is equal to, from the effort to the fulcrum it is 15 centimeter. Then load arm, the complete length of the fire tongue is considered as load arm. Why? Because here we are applying a load, okay, from this point to fulcrum it is 20 centimeter. So it is nothing but 3 by 4. 3 by 4 is nothing but 0.75. That's it, mechanical advantage. See, if you understand the concept it is very easy to do the calculations. Next we need to find effort. Effort will be equal to load by mechanical advantage. See, load is equal to how much they are talking about, 1.5 kgf, 1.5 kgf, and mechanical advantage is 0.75. So 1.5 divided by 0.75. see, you can use any method to calculate the answer. There is no rule that you have to calculate in this method only or any method. If you can logically solve this, the answer will be 2 kgf. Why 2 kgf? Because we are finding effort. Okay, what is the unit of load? Kgf. That is why unit of effort will also be kgf. Now we have completed all the numericals from this part. We have learned the concept video. After that we have solved all the theory questions from this chapter. Not only this chapter, we are going in this way only, okay, in this order. First we will learn the concept, then we will apply whatever we have learnt in theory questions which is given in the textbook exercise part. After completing all these things, we are going to solve numerical. That is what we have done. So in this way we are completing everything. So once you do like this, you will have the complete knowledge about this topic. Then any application question based on this topic will be a piece of cake for you. Aram se you can solve it. Thank you.